Good day, everyone, and welcome to our lesson 8, which is continuation from lesson 7. Today, we'll be doing converting decimals into fractions and then also working with decimals in terms of rounding off. So, let's take a look into our lesson for today. So before we start with lesson 8, we're going to start by revising what we did on lesson 7, which is also going to help us understand more better concept in terms of lesson 8. So on lesson 7, we did cover fraction using the 4 basic operation, where we did the adding and subtraction of fraction. And we also learned that for you to be able to add or subtract fraction, you need to have a common denominator in both the fractions. So if the fractions do not have the same denominator, therefore we'll have to find a lowest common denominator for both fraction and therefore convert both fraction based on the lowest common denominator. And then from there we can add the numerators. And then we also covered the multiplication, where we did cover some of the steps that are involved in multiplication, where you have to, the rules are that you have to multiply the numerator with the numerator and the denominator with the denominator, and then the third step was to actually simplify the fraction. And then lastly is that once you simplify the fraction, if it is still an improper fraction, you have to convert it to a mixed fraction. And then we also covered the division, where under the division we did mention that if you are dividing a fraction by another fraction, the division sign will change into a multiplication sign, and then also your second fraction that is dividing the other will have to be flipped around, where the denominator becomes the numerator and the numerator becomes the denominator. So this is what we all covered in terms of lesson 7. We also performed some practical questions. So if you still have got challenges with the lesson, please make sure that you revisit the video or the recording, learn more again, try to do more practice questions, and then if you still struggle, you can contact me for assistance, then I'll be able to help you. So for today's lesson, we'll be covering page 93 to 100, which is our lesson 8 from our textbook Finance in Media. The subject or the lesson content will be converting fraction to decimal and understanding types of decimals that are there within each and every fraction. So by the end of today's lesson, you should be able to have achieved the following: appreciate the application and relevance of decimal in everyday situation, know how to round off decimals and calculate which decimal, working with various forms of decimal, non-terminating, terminating, recurring, as well as converting fraction to decimal and converting decimal to fractions, and lastly to round off decimals. So our first part for today's lesson is working with decimals. So I'm just going to switch to our textbook. So in terms of our textbook, it says that we work with decimal numbers each and every time we make a purchase, receive a paycheck, or even when we convert currencies. So this is 100% true. This is what we always come across every time we go shopping, every time you receive your allowance and you start spending money. So some of the balance that are remaining, they will always have what we call decimals, or some numbers will actually not start to add up because you'll be having decimals within your numbers. So therefore, under this lesson, we'll be understanding decimals and how they get to be calculated, converted, and as well as to how to round off the decimals. So here it's talking about the first part of the activity, which is that as you know that the cents are written as 0.95, so we can call this number a decimal or a decimal fraction. So a decimal fraction, it means that the number represents a fraction, but it is written in decimal format. And therefore, if it also continued to say that decimal are unique fraction in which the denominator are powers of 10, such as where 10 is equal to 10 to the power of 1, and 10 squared it's gonna be within the 100, and 10 cubed is equal to 1000. So this, and continue going forward to say 10 to the power of 4, that will be 1 million. So just like that is continuing. So the first lesson that we're going to cover is actually converting fraction into decimals. So I'm going to show you how to convert fraction into decimals without the use of a financial calculator. And then later on, I'm going to also show you how to convert decimal back into fraction without a calculator. Even though the values that you're going to get are not going to be the exact as the one that you actually started using by. So what you're going to do is that once you get your final values, once you convert decimal back to fraction, you will still have to simplify if it can be simplified until you get the lowest version of that fraction. So under today's lesson, I'm going to be using Excel so that I can show you guys in a better way of how we get to reach the decimal point. So I'm going to use the example first that is on the textbook, and then from there I'm going to take some activity example and we're going to perform them here. So fraction to decimals. So when you perform fraction to decimal, you're actually asking yourself question, or you're actually uh, calculating how many times can the denominator goes into the numerator, and if there is a remainder, therefore we're going to also be checking that remainder and how we can actually eliminate the remainder until. So in terms of converting fraction into decimal, so the following rules apply. So we're going to start with the first one, which is 35 out of 100. So to convert 35 out of 100, this is going to become 0.35, which we are already aware of. Some of you are already aware, but now I'm just going to show you how to actually get to 0.35 without the use of a calculator. So when you have got a fraction like this, the first step that you do is to ask yourself, can the denominator go into the numerator? If no, therefore you're going to put 0 and then you're going to put your comma within after your first number. Then after that, once you do this, you're going to go and add a 0 on that number all the time. Even if the number can goes there multiple times and leave a recurring number, you're going to still add a 0 on the recurring number, and then recalculate again until you get a final amount that does not require you to continue calculating recurring decimals. So therefore, under this one, we've got 35 over 100. So we're going to say that if does 100 goes into 35? Nope, it does not go. So therefore, we say 0. And what we're going to do is that we're going to go and say 35 and we put a 0 then next after the 5, and then go and say divide by 100. So therefore, this means that it's going to be now 350 divided by 100. So therefore, when it's like this, we know that it's gonna go 3 times, but when it goes 3 times, it's gonna leave 50 behind. So once it leaves 50 behind, therefore this is the remainder. So therefore we're gonna add a 0 on that remainder. Therefore we're gonna be left now with 500. So therefore we're going to say how many times does 100 goes into 500? That's gonna be 5 times. So therefore we have our 0.35. So if we go and use our financial calculator, it's gonna give us 0.35 as a final answer to show that 35 out of 100 it's equaling to this. So the method that I just quickly show you now, it's how to convert fraction to decimal without a use of a calculator. So every time you ask yourself how many times does your denominator goes into your numerator, if it leaves the remainder, you're going to write down you're going to crash out the number that you wrote, put in the recurring decimal, the recurring or the remainder, and then you're going to add a 0 and then repeat the same process until you do not get a remainder. Therefore, that will be your final answer. And then when you're working with mixed fraction, so when you're working with mixed fraction, if you're not aware, I'm going to start with the long version and then show you the simple version. So the long version is that you first convert this back into an improper fraction because it's a mixed fraction, which we are going to say 5 multiplied by 7, which is going to give us 30, and then we're going to say plus 2, that's going to give us 32 over 5. So we're going to have 32 over 5, which is going to be an improper fraction. Then from there we're gonna go and see how many times does 5 goes into 35. That's gonna be 7 times, so we're gonna go and say 7 comma, and therefore it's gonna leave a remainder of 2. So then go and put a 2. Once we put that 2, because it's a remainder, we're gonna put a 0, therefore, and says 20. Therefore we're gonna go and say 20 divided by 5. Therefore, or how many times does 5 goes into 20? That's going to be 5 times. So therefore, we have got 7 comma 5. So this just shows that once you have something like this, it just shows that this will be our final answer as 7 comma sorry, not 7 comma 5. Let me just quickly confirm this so that we make sure that it's 4 times, not 5 times. So it's 0 comma 4, not 5 times. So 5 goes 4 times into 20. So our final answer is 7 comma 4. So this is how you get to convert. So I'm going to apply the second one. So on the second one, it says that 7 out of 250. So we're going to start with the first step. How many times does 250 goes into 7? 0 time, it doesn't go there. Therefore, we're going to go and say 70 and put a 0 on the next to the 7 and say 250. And then we're going to say how many times does 250 goes into 70. That's still 0. So that will be 0 comma 0. And then we then again put another 0 on our then we put another 0 on our number here next to our 70, which means it is now 700. So we're gonna move forward and say 700 divided by 250. How many times does 250 goes into 700? It's gonna go 2 times, but it's gonna leave a remainder of 200. So therefore we're gonna go and say it's gonna be 0 comma the first one we said it can't go, that's 0, and then we put a comma and say on 270 it can't go. Then into 700 it can go 2 times, and then we're gonna move towards now the 200, which is the remainder, and then we're gonna add a 0 on the 200, which is the remainder, because 250 plus 250, that's 500, that's 2 times, and therefore the remainder is 200, and we add a 0. Every time there is a remainder, we're gonna add a 0. Therefore we're going to see how many times does 250 go into 2000. So that will be 2 times in 500, 4 times in 1000. So therefore that's 8 times in 2000. So therefore our final answer will be 0 comma 8, 0 comma 028. So this will be our final answer within our scenario. So if we go and do this on a calculator, this is the value that we're gonna get. So I'll just do that as part of confirmation for you guys. That's still gonna get the same amount. Divide by 250 is still gonna give us 0 comma 028. So do not mind about the decimals. My calculator is running off to the nearest 5 decimals, so it's gonna show up to 5 decimals. But if I run it off to the nearest 2, it's gonna say 0 comma 03. So depending on how your calculator is set up, so it might only show you only 2 decimals. And then we can move forward to the third question, which is 3 out of 8, which is an improper fraction. So which is a mixed fraction, which can still be converted to an improper fraction. So under this second question that we did of 7 2 out of 5, I showed you the long version of actually converting an improper fraction to a proper to decimals. So under this one, I'm going to show you a simple version that we are going to apply within this activity. So instead of us converting this into an improper fraction, what we're gonna do is that we're gonna, instead of saying 4 times 8 plus 20 plus 3, giving us a value of which is gonna be the numerator, we're not gonna apply that because we know that it's gonna take us back here. So this 4 serves as a whole number, so therefore we're gonna write it as a whole number and put a comma. And then once we put a 4 and then put a comma, we're gonna put a 0 within our fraction. And then once we put a 0, then go and ask ourselves how many times does 8 goes into 30. So therefore it's gonna be 8 plus 8, that's 16, plus 8, that's 24. Then we're gonna have 60, we're gonna have a remainder of 6. So meaning that it goes 3 times and leave a remainder of 6. So meaning that we're gonna have 0.3 here, and because it goes 3 times, and then here we're gonna remove this and say it's gonna leave a remainder of 6, and then once it leaves a remainder, we're gonna put a 0 next to that remainder. That now gives us 60. So therefore we can go and say how many times does 8 goes into 60. It actually goes 7 times and leave a remainder of 4. So meaning that it goes 7 times, so we're gonna have 7, and then since it leaves a remainder of 4, we're gonna write that 4 here and then put a 0. And then we ask ourselves another question: how many times does 8 goes into 40? Therefore it actually goes 5 times, so therefore we're gonna have 5. So therefore our final answer becomes 4,375. So when you see a mixed fraction written as 4 3 out of 8, so it means that 3 out of 8 represent the recurring decimals and 4 represent the whole number, which was how many times from the improper fraction. So this becomes the whole number, this becomes the decimals, so therefore that will be representing that. So here it was 3, so our final part was saying 40 over 8, which gives us the 5. So if we go on our calculator and say 3 out of 8, it's gonna say 0,375. So this just represent this. So the fraction that we have under the mixed fraction, which is the fraction that will be there, will be representing the decimals. So that is all in terms of converting fraction into decimals. So let's take a look into our lesson and see what it continues to say. So we already covered the converting fraction into that. So these are the activities that we were busy performing. So I've got 5, 7 out of 15. So let's try and perform this one and see how much we're gonna get if we were to perform that. So 7, 5, 7 out of 15. 5, 7 out of 15. So let's try to work this one out and see what we're gonna get. So when it's like this, we already identify that this is a mixed fraction. So we already have 5 as a start. So once we put that 5 as a start, then we're going to put a 0 next to the 70, and it's going to become 70. So therefore, once it becomes 70, to say 70 out of 15. So we ask ourselves how many times does 15 goes into 70. So we know that into 30, it's going to be going 2 times. Into 60 is going to be going 4 times, so therefore we have got 5,4 already, but it's going to leave a reminder here because 15 cannot go into the remainder, which is 10, so therefore we're going to have a remainder of 10, and then we're going to add a 0 on that remainder. So therefore we're going to put another 0 and say now how many times does 15 goes into 100. So therefore we're going to calculate to say that okay, in 30 it goes 2 times, in 60 it goes 4 times, in 90 it means that it's going to be going 6 times, but it's going to still leave a remainder of 10. So therefore we're going to have a 4, and then from there again it's going to leave a remainder of 10. So meaning that this is going to be a continuing series of having us a remainder of 10 all the time. So since we have 10, it's gonna just go back to 100. So meaning that we're gonna have something like 5,444444444 up until infinity. So therefore, if we go and say 7 divided by 15, we've got 7,465. So I think I miscalculated some of the remainder. So let's just recheck that one up. I might have made a mistake. So we're saying 7 out of 15. So we already have 5. So therefore we've got 0,44. So we don't have 0,44 so far. So we're saying that once you put the 5, you're going to put your 70. Once you have your 70, then we're going to go and say from the 70, how many times does 15 goes into 70? So we said that's 4 times, and then it's going to leave a remainder of 10, because from 60 to 70 that's going to be a remainder of 10. So we're going to have our remainder of 10 and add a 0, and then we're going to come this side, so we're going to have 4, and then this side we're going to say 15 into 100. 15 into 100 is 6. I think it was me who made a mistake of typing error here. So it's going to be 6 times and leave a remainder again. So what will be the remainder that will be left? So the remainder will still be 10. because we are talking about 15 going into 100. So we know that 15 cannot go into 100 and do not leave a remainder. It will leave a remainder. So we know that into 90, 15 can go 6 times, but it will leave a remainder of 10. So that remainder of 10 will still be 100. So therefore, we need to do that. So it's going to continue to say 4 comma 6, and therefore we have 4,6666666 going upwards. So this will be the remainder. So if I go into my calculator now and change my decimal to say I want the decimals to be 9, you will see that it's gonna say 7 out of 15 is 0,466666, and the last one will be rounded because the other coming 6 will be above 5, so it's gonna take this one to 7. So therefore this is the fraction that we actually get to have as decimal. So this is the decimal fraction, which is 0,466667, which is equivalent to 7 out of 15. So that is all in terms of recurring decimals or converting fraction into decimals. So these are the one on your textbook that we are already familiar with. So some of the concepts that we are already familiar with is things such as 1 out of 2. So we do know that 1 out of 2 is equal to 0,5. So the reason it's 0,5, when we're calculating it without a calculator, it will look like this. So we're going to go and say 2 into 1, that's gonna be 0, and therefore we're gonna left add another 0 on the 1. Therefore we're going to say 10 divided by 2, it's gonna give us 5, which means that 2 goes 5 times into 10. So that's how we get to 0,5. We also know that 1 out of 4 is actually 0,25. So therefore under this case we're gonna say how many times does 4 goes into 1. That's gonna be 0, and then we're gonna go and say let's add a 0 onto the 1 because we already have a 0 this side. We already solved for 1, and then we say 10 divided by 4, then that's gonna give us 2 times, so it's gonna go 2 times. So 4 will go 2 times into 10. So here's 4, so it's gonna go 2 times into 10, and then it's gonna leave a remainder of 2, and then once it leave a remainder of 2, we always add a 0 on the remainder. So we're gonna add a 0, and then we're going to say 4 into 20, that's gonna be 5 times. So therefore our final answer become 0,25 because it didn't leave a remainder this time to be calculated going forward. And then from here going forward, we're gonna see what we have on our lesson. So you can please do the activity 2M and N on your textbook, and then if you still struggle with those, then you can request the assistance. Then in terms of decimals, if you did notice from our activity here, we have got 0,25, we've got 4,666666666, 5,4666 going, and something that looks like this 4,37. So all this type of decimal, they have got definition, and this is the definition of each type of decimal. So we've got something called the non-terminating decimal. So non-terminating decimals, we are referring to those decimals that looks like 3,1456788 212 like this. So this is what we call non-terminating. So when you calculate this, it's always gonna be having a reminder when you try to ask yourself how many times does your denominator goes into the numerator. So meaning that there will always be a recurring, and that recurring will not give you a whole number once you divide the numerator by the remainder by the denominator. So it's gonna always lead you to calculate something else. And then from there, meaning that you will calculate until you run out of space. So we call those non-terminating, so they do not end. And then we've got the one that ends, which are referred to terminating decimals. So in terms of terminating decimals, they are referred in the following manner. So terminating decimal is a decimal that is exact and complete. For example, we've got 0,25. So 0,25 are terminating. They do not continue after a certain number. So which means that, for example, we've got 4 3 out of 8. So 4 3 out of 8, it's what we call a terminating. So it reaches a point and then it ends, meaning that once you're trying to divide the number on top, there is gonna be a point where you're gonna have the numerator being a number that is falling within the same um, number system as the one dividing. For example, you might be finding that the numerator will now fall within the even number, and the number dividing is also an even number, and they fall within the same multiplication. So meaning that once you divide that, you're going to have a final answer as a whole number. So therefore we refer those as terminating. And then the last one that we have is recurring. Recurring is the one that we just performed now, which is 5,4666666. So the number that is coming behind the commas, it's actually repeating until. So those are what we call recurring. So now we are going to try to work with converting decimals into fractions. So let's take a look into that and see how does that work. So before we convert decimals into fraction, I will start by actually covering something on the lesson so that we can understand under why we are saying that in terms of converting decimals into fraction. So when you convert decimals into fraction, the following things actually happens that you need to understand. You're gonna be having something that looks like this to say that you're gonna have your first number, and then you're gonna have your comma, and then you're gonna have decimals that are coming behind the comma. So these numbers represent values. So this number that is before the comma will represent the ones, and then any number after the comma will therefore be under the tenth, and then this will represent the hundredth, and this will represent the thousandth, and this will represent the 10,000. So meaning that if you have got 0,1, that is the same as having 10 that's the same as having 1 over 10. And then if you have got a number within 100, 0,01, that's the same as having 1 over 100. And then if it's within the 1000, that's the same as having 1 over 1000. So each and every value here represent it's have got its own place value. So if you remember, we did cover the place values, which I'm going to explain using this example here, to say that last time when we prepare the place values, we said that when we count from right to left, starting from here before the commas previously we didn't have this. So we did say from 1 we've got the ones, from 2 we've got the tens, from 3 we've got the hundreds, from 4 we've got what we call the thousand, and 5 we've got the 10,000, and 6 represent the 100,000. So we said that if we're to read to the value of 2, we'll say it's 20. And then if we're to read the value of 3, we'll say it's 300. And if to read the value of 4, we'll say it's 4,000. If to read the value of 5, we'll say it's 50,000. If the value of 6 will be 600,000. So what now happens when we're working with decimal is that when we start counting from the comma going at the other side, the ones will remain the ones within this spot, and then anything that will start counting from left to right this time, therefore we're going to have the number behind the comma as the tens, and then the number after the comma as the hundreds, and then the thousands, and then so they will still keep the same value, but this time they're keeping them in terms of decimals instead of just an ordinary value or just a place value that we're used to. So now we are referring it under what? Place values. So the one remains within the same spot, but if we're counting from left to right, we're just gonna say 1000, we're gonna say tens, hundreds, and still same apply when you start counting from behind the comma, because we already have our one standing in between. So when we start counting the other side, we're gonna have the tens. So here we're gonna have the tens, the hundreds, the thousands, 10,000s, and the 100,000s. So it's gonna continue with the same pattern. So that is why I wanted you guys to understand that, so that when you're working with the conversion of decimals, you understand why we're gonna be calculating that based on. So here we've got the ones, the tens, the hundreds, the thousands, and the 10,000s. So when we're working with decimals, so this will become 1 decimal, 2 decimal, 3 decimal, and 4 decimals. So the moment we said 1 decimal, that means that we are on the 10th. tenth have got 1 0, and then when we say hundreds, hundred have got 2 zeros, so we're going to be working with 2 decimals. And we say 3 decimal, we'll be talking about the 3 zeros, which is within the thousand. And we say 4 decimal, we're working within the tenth thousand. So if it says round off to the nearest hundreds decimals, so which means that you have to identify that we are working within the 2 decimals. If it says round off to the nearest tenth, therefore you are running off to the nearest tenth decimal, you are running off to the nearest uh, tenths, which is 1 decimal. So let's go take a look in terms of our activities. So this is the part that I was busy explaining to you guys, that here we're going to have our whole number, which is the first the ones, and then we're going to have our 1 decimal, 2 decimal, 3 decimal, and 4 decimal, which if we go back this side, the 1 decimal represents the tens, then the second decimal represents the hundreds. So converting this back to decimal, so what we're going to do is that if you take a look into this activity, we have got what we call non-terminating. So it could have continued going forward, but I actually rounded it off. So instead of allowing it to continue going forward, I just rounded it off to 3,142,857. So when you have got non-terminating, you'll actually have to round them off to somewhere to the nearest point to say that let me round off this to the nearest 2 and get something that is accurate to 3,14. So if we are to round off this, so we're gonna have 3,14, something that is equivalent to 3,14 will be calculated as follows. So we know that 3 is a whole number, so therefore we're still gonna have our 3 this side. Once we have our 3, what's gonna happen now is that we have got our 3 as a whole number. Then we're gonna say, let's take a look at the numbers behind the decimal. How many numbers do we have? We've got 2 numbers, 1, 2. So our decimals are in hundreds. So therefore, we're gonna have our 100 as a denominator, and then the top part will be 14. And therefore, we take a look in terms of the 14. Can this 14 be simplified? 14 out of 100. Can this be simplified? Yes, it can be simplified. If we divide 14 by 2, we're gonna get 7, and if we divide 100 by 2, we're gonna get 50. So if you go on your calculator right now and says 3 whole number 7 out of 50, you're gonna get 3,14, because we have managed to round off this to the nearest 14. So if I just take mine right here and say 7 out of 50 to calculate the decimals after the whole number, so it's gonna give me 0,14, meaning that the final answer for this will be equal to 3,14. So then in terms of the ones that are recurring, also the ones that are recurring, you cannot convert them into a fraction unless you round them off. So when you round them off, you'll actually have to round off this to the nearest 2 decimal or 1 decimal. So therefore 0,66666. So we'll take a look in terms of the numbers that we're actually seeing here and see, can this number be simplified, since it's a recurring and recurring. So for this number, we could write it as we calculate the decimals to say we've got the tens, the hundreds, the thousand, and the 10,000. So therefore this is equivalent as 6,666 over 1,000. So it will be equivalent to something that looks like this, to say that if you go and calculate this, it will give you 0,6666, and this can actually be simplified as well. So you can go and simplify this and then get a different figure. So non-recurring, it's very hard for them to be converted because they continue until infinity as 0,6666666. So therefore you might end up having to cut off some amount to get the significant value of that decimal. So sometimes you might find that this 0,6 could actually be rounded off to say that if you are calculating two decimal, that will be 0.67. So that now it's under two decimal, we're going to be having two digits. So therefore those two digits will represent 67, and because they are two, that will be out of 100, 100. So therefore this represents the tens, this represents the 100. So we're going to have 100 as our denominator and 67, and we can ask ourselves, can this be simplified? If no, therefore we leave it just like this, and that will be the end of it. And then comes to the normal ones that we are used to, 0.25. So to convert 0.25 into a fraction, we're going to calculate the numbers that are behind the comma and then identify under which place values they are within. So we've got 1 and 2 decimals. So 2 decimals that are 100. So therefore, this is the following fraction that we'll have. So we're going to have 25 over 100. So once they are within the hundreds. So 25 out of 100 can be simplified. So if we go and say 25 divided by 25, we're going to get 1. And if we go and say 100 divided by 25, we're going to get 4. So meaning that the simplest equation for 1 out of for 25 out of 100 will be 1 out of 4, which we are already aware that 1 out of 4 is equivalent to 0.25 as a decimals. Same applies to 0.5. When it comes to 0.5, we just have to do the same principle. What is the value? What are the numbers of value behind the commas? So we just take a look into that. So the number of value behind the comma is 1. So 1 represents tenth. So therefore, 1 decimal represent is the equivalent to the tenth. So therefore we're gonna have 10 as our denominator, and then we're gonna have the 5 here. So therefore we're gonna have that 5 here, meaning that our fraction for this is equal to 5 over 10, which 5 over 10 can be simplified and get an equivalent fraction which is smaller. Therefore we can divide everything by 5 to get an equivalent fraction. So therefore 5 divided by 5 it's 1, and 10 divided by 5, that will give you 2. So therefore you have got a simplified version which is equivalent to 5 out of 10. So 0.5. So that is it in terms of calculating recurring decimals. So sorry, not calculating recurring decimals, but converting decimals into fraction. And then we have got 0.42. So under 0.42, we're gonna calculate it to be the following. So the values, we've got 1 decimal, 2 decimal. 2 decimal represents the 100. So we're gonna go and say 100. And then we're gonna look at the number behind and say it's 42. So therefore from there we can try to simplify this. Can this be simplified? Yes, it can be simplified. Let's start by dividing everything by 2. So when we divide everything by 2, then from there we can get a simplified version of all of this. So therefore we are going to have 42 divided by 2, and that's gonna give us 21. So we're gonna have 21, and then here we're gonna have 50. And then from there we can ask ourselves, can this still be converted further or be simplified to say 21 out of 50? Okay, is there a number that can actually get to give us a simplified version of 21 out of 50? Is there a prime number that we can use to simplify this fraction? If there isn't, therefore we leave it as 21 out of 50. So if we go and say 21 over 50, we're still gonna get what? 0.42. So therefore it's simplified under its best version if there is no other number. But if it's an improper fraction, therefore we'll have to actually convert that into a mixed fraction. So that is it in terms of working with fraction, in terms of decimal to fraction and fraction to decimals. And then the last part is to round off, to say that if we say round off to the nearest 3 decimal, we are still saying that round off to the nearest 1000 decimals, because the 3 decimal represent the thousands. So therefore under this one we're gonna calculate how many. We're gonna go to 3 to the value of 3 decimal. We've got the first one, the third, second one, the third one. So it's this one. So from this one So we're gonna be having this one, and we're gonna go and ask ourselves, what is the number behind the third decimal? So is it above 5 or it is below 5? If it's above 5, it's gonna change this one and therefore change it to 4, and if it's below, we're gonna remain the same. So under this one, we're gonna have our answer being 23 comma 333, 333 cents, or 333. So this will become the new number. So the other numbers, you do not write them there. So if you take a look into this one, it says that we've got 0.987654. It says round off to the nearest 10th decimal. So if we're running off to the nearest 10th decimal, 10th decimal is the first decimal, which is, so 10th decimal, okay, yes, 10th decimal, so it is equivalent to 1 decimal, not 2. So that will be equivalent to 1 decimal. So the 10th decimal is this one here, which is our 9. So if we're rounding off to the nearest 10th decimal, we're going to take a look at the number behind the 10th decimal, which is the 1 decimal, which is going to be 8. And 8 is above 5, so it's going to change 9. So we need to change this one. Therefore, this becomes 10, and 10 for becomes a whole number if we are from a behind the comma. So therefore, we're going to have our final answer being 1. So this is converting fraction into, so this is rounding off the 10th decimal to 1 decimal, which is equivalent to 1 decimals. So this is the 10th decimal. So if the number behind here was actually 4, so therefore, when we run this off, we're going to take a look at our 9 again to say this is the 10th decimal, so which is the 1 decimal. So therefore, we look at the number behind, which is 4. So therefore, our final answer was going to be 0.9, because it wasn't going to change what our 9 into a next value, which is going to be 10, and therefore we're going to have 1.0. So therefore, this time we're going to just have 0.9. And then in terms of the last part, which says 11 rand 62. So if we say round off this to the nearest one value, you're gonna take a look at 11. This is the ones value, or the rand value. So the rand value start from 1, and then if we say 10 rand, the 10th rands, therefore you're gonna look at the 10th rands. So if we said 10th decimal, therefore you're gonna look behind the decimal side, and then it just says 10th value, then you look in terms of the value counting from right to left. If we're talking about decimals, we count from left to right after the comma. So in terms of the rand value, calculating this or rounding off this to the nearest rand value, therefore that will be taking a look at the rand value, which is 1, and therefore look at the value behind the comma. Is it above 5? Yes, it is above. So therefore when we round this off, it's gonna become 12 rand. So therefore that will be the new value for 11 rand comma 62 cent if we're running off to the nearest one value or rand. So therefore we're gonna have 12 rand. So this is all in terms of today's lesson, which is converting decimals into fraction, and this fraction into decimals, as well as rounding off. So let's take a look in our textbook and our slides to see if there is anything else that we didn't manage to cover, and then from there that will be the end of the activity. So here they're talking about calculate rounding of decimals and calculating with decimals. So you can do the calculation with decimals. So on your book, it did shows you how to calculate with decimals, which I'm just gonna go there. We covered converting, rounding off. We also covered that. So the last part will be actually adding decimals. So if we're to add decimals, so what we do is that when we're adding decimals, so I'm just gonna clear everything that is here. So if we're adding decimals and we've got 0.523, and then let's say we also have got 0.6514 and 4. So if we have got decimals like this, so the most important thing is that when you're adding decimals, make sure that you align them based on place value. So meaning that you're gonna align them based on place values. So you're gonna align them. On my side, I will align them like this to say that this is my place values. So since this one was adding with a 3, so I'll make sure that it shift a bit so that it can, the values can be under the same, and so the same space. So therefore I can be able to track which one is which one. So in terms of adding, we're gonna start from right to left. So we're gonna go and say this one didn't have a value on the thousand, but the second decimals have got the value within the thousand. So that will be 4 plus nothing. So that was gonna give us 4. So meaning that we're gonna have that 4 here as the first start, and then later on we're gonna go and say 1 plus 3, that's gonna give us 4. So therefore we're still gonna have another 4, and then we're gonna move forward and say 6 plus 2, that's gonna give us 8. So therefore we're gonna put our 8 down there, and then we're gonna go and move forward and say 5 plus 1, that's gonna be 10. So meaning that when it becomes 10 a decimal, so therefore that value, the 1 will come to the what we call will move towards the ones, and then the 0 will remain on the decimal place. So therefore it was 11, we're going to have the 1 this side and the 1 this side. So therefore under this one we're saying that it's going to become 10th. So therefore we're going to have 1 on the other side and then 0 on this side. So therefore this will add up as 1,0844. So we can do that by going and adding this manually and see if the value will be the same. So yes, the values are the same. So this is how you get to add. Same thing that as when you're multiplying. So when you're multiplying, you multiply this first with everything that is above here. To say 4 times 0, that's gonna give you 0. And then you go and say 4 times, let me just write this a bit down. Then you go and say 4 times 3, that's gonna give you 12. So you're gonna put 2 and carry 1 on top of the of the 2, which is gonna become 3. So therefore you go and say 4 times 3, sorry, say 4 times 2 and then plus that 1, that's gonna give you 8, and then you're gonna have your 9, and then you're gonna say 4 times 5, that's gonna give you 20. So you're gonna have the 2 going on the other side and the 0 remaining that side. So therefore you're gonna have 2 comma 0 on the first one, and then you repeat this until you're gonna repeat this until all the numbers are done. So it is the same as multiplying 12 multiplied by 4. So if we were to multiply this without a calculator, we're just gonna say 4 multiplied by 2, that's gonna give us 6, and then say 8, and then we're gonna go and say 4 multiplied by 1, giving us 4, and then we're gonna say this is the final answer, which is 48. So you still apply the same principle of multiplication when also working with decimals. So therefore you're gonna have your final answer. So this one I'm just gonna leave it to you guys to just work around it, and it's not something that it is highly important that I could say that so the only thing that I could advise that you practice on this is mostly adding and dividing decimals. Sorry, adding and subtracting of decimals, because these we normally came across when you're working with change, when you're trying to add numbers which are including currencies. So you'll have to work with the 2 decimals. So you need to be able to understand those. So please just work on those and also perform the activity 2Q just to test your understanding in terms of the addition and subtraction, and then you'll be able to see if you are able to have achieved the outcome of being able to add and subtract decimals. And I believe that will be the end of our lesson. So please take a look in terms of our next lesson, which is our lesson 9, which I believe on lesson 9 we're going to be doing mostly revision, and lesson 10 revision of what you'll be writing in terms of your assessment. And then after that we're going to start with lesson 11, 12, 13 and continue going forward. And one of the important things that I also want to mention is that um, you're also going to be given an assignment at the end of the semester, which the assignment will also be contributing some specific percentage. So please make sure that you stay tuned in terms of what is going to be covered in class. Please attend class regularly so that you get to ask your question if you're struggling. If I'm talked about something that you want a different explanation, I can be able to change that, but through recordings you won't be able to get to have that opportunity. So attending class allows you those opportunities. So please make sure that you use those opportunities wisely. Attend class regularly, and I'm also monitoring your class attendance. So please make sure that you attend class regularly, ask question where it's required to, and make follow up where you need to make follow up. So in absence of that, that will be all for today. Enjoy the rest of your day. We shall meet next time on our next lesson.